Welcome back, everyone. We're now going to talk about Euclid Book 2, proposition number 6. I bet you're getting tired of these, but trust me, there's a reason for all this. Okay, we're approaching Euclid Book 2, proposition 11, which will prove the quadratic formula geometrically. Alright. Euclid, first of all, wants you to draw a line. He wants you to draw a line from point A to point B. And then he wants you to bisect that line at point C. Now, do you remember how to do that? Well, if you don't, you need to go back to Euclid Book 1, proposition number 10. But if you do know how to do this, we need to go on. Alright, now, we have a line. It starts at point A, it goes through point C, it ends up at point D, but then we're going to extend point B to point D. So now we're going to have this great big line starting at point A, passing through point C, passing through point B, and ending at point D. Okay. Then Euclid wants you to draw a line, well, not draw a line, but draw a square, and that square is going to be C, E, F, D. C, E, F, D. Okay. And then what Euclid wants you to do is he wants you to draw a line from D to E. Okay? And then he wants you to draw another line from point B to point G. And then he wants you to draw one last line from point M to point K. And of course you're going to draw this point K to point A. Now you've got your whole figure here. What you've got now is a square called CEFD, and you have a gnomon. A gnomon which is NOP. Rectangle N, square O, rectangle P. Now, how do you know that this is a square? Well, we're going to prove that in a little bit. But let's go on here. Euclid says he wants you to have a parallel line AK to CL. Well, AK is here, CL is here, they're parallel because of Book 1, proposition number 31. And then he goes on to say that AC equals CB. We already proved this by Euclid Book 1, proposition number 10. Alright, now Euclid says that AKLC is equal to CLHB. CLHB. Okay? He says that. Then he goes on to say that CLHB is equal in size to HGFM. HGFM. Let me go back over here one more time. HGFM is equal in size to CLHB. These two are exactly the same size. And since these two are exactly the same size, and these two are exactly the same size, then this rectangle here is exactly the same size as this one. So you got AKLC equal in size to HGFM. Alright, and that's the transitive property. Now, if we were to add CLMD, okay, this whole thing right here, CLMD, if we were to add that to AKLC, and we were to also add it to HG, here's H, G, F, and M, then we could finally say that AKMD, okay, AKMD, this whole length right across here, this whole area, is equal to the gnomon NOP. Alright. Now, I'm going to go on with this proof in the second part of my video, so stay tuned.